Good morning. Welcome back, ladies and gentlemen. I'm proud to be able to introduce a longtime friend. And let me highlight just 3 things from his extensive biography, which you all have. First of all, he's a Rhodes Scholar and attended Oxford, earning degrees in international relations and politics. So in this academic setting this morning, I'm sure he feels very much at home. Second, and this is really important, he had multiple assignments while on active duty with the Air Force in North Dakota. Bully. Both in Grand Forks and very importantly, serving as commander of the 91st Rough Riders at Minot Air Force Base, which is where I met him and we became acquainted. And the third thing I'm going to highlight is that he served as the military attaché at the embassy in Moscow. So in the meantime, and in other things, he's done important work for the nation, like standing up Air Force Global Strike Command and some other stuff. But I think it's really important to recognize those key things. So today, he is the Department of Energy Undersecretary for Nuclear Security and the administrator of NNSA. Please welcome Frank Klotz.
Well, thanks, Mark, for that very generous and warm introduction. I'm delighted to be here. Joe and I talked about this, I don't know, 2 years ago, 1 year ago, so it's absolutely a delight to be here with you and the other members of the coalition, many of whom are in locations more closely associated with the Department of Energy and the National Nuclear Security Administration than with any of our global strike and Navy bases. So I'm delighted to see them as well that are here. A lot of things were said about the guests that were here, and I won't repeat those, but I would like to give a shout out to our industry people who are here today, because one of the fundamental tenets, and I probably will say something about that as we go through my prepared remarks, I think one of the fundamental tenets of deterrence goes beyond the forces, be they aircraft, missiles, submarines, and it goes beyond the front end of the weapon systems that we have responsibility for. It even goes beyond doctrine, strategy, concepts. It has to do with that scientific, technical, engineering, industrial base that supports all of that. That was something that was recognized by the leaders of this country during the Second World War and in the early days of the Cold War, and I think it's just as important today as it was then, that our scientific, technical, engineering, and industrial base is a key pillar of deterrence and will be for years to come. So I'm glad to see so many folks here from industry, and many of whom are people I've had the great pleasure of working with for a number of years. I'm also delighted to be here to represent the Department of Energy and the National Nuclear Security Administration. I'm told that the vision of the Strategic Deterrent Coalition is for the United States to maintain a modern, safe, secure, effective, and stabilizing nuclear triad deterrent. That's fortunate because most of my remarks this morning are going to focus on the unique and special responsibility that NNSA has in providing for a credible deterrence. The NNSA and the Department of Defense both play a critical role in this endeavor. NNSA by ensuring that America's nuclear weapons are safe, secure, and reliable, and the DoD by ensuring that they can be delivered effectively. NNSA and DoD's respective efforts in this joint endeavor are coordinated through the congressionally mandated Nuclear Weapons Council that Admiral Haney referred to earlier today. Within this venue, our two departments work together to determine options and priorities, which in turn help shape national policies, and budgets affecting the development, production, and retirement of America's nuclear weapons. So what I'd like to talk about today, before I take your questions, is to highlight several of NNSA's recent accomplishments and describe some of our plans for the future. But before I do, I think what I'll do is lay out a little bit about the range of NNSA's mission space, primarily for the benefit of some of you who may not have had the opportunity to work directly with us before. Now, even though NNSA's heritage can be traced back to the Manhattan Project during World War II, it's a relatively new government agency as far as government agencies go. In fact, NNSA was only established by law in 1999, came into existence in 2000, the year 2000, as a semi-autonomous organization within the Department of Energy with responsibility for enhancing America's and our allies' national security through the military application of nuclear science. Now, this very general job description encompasses a lot, but at its most fundamental level, it means that we harness science, technology, and engineering to ensure that the nation's nuclear warheads are safe, secure, effective, reliable, credible, as well as to address many other important security challenges. These include, and are a very important part of our mission set, preventing, countering, and responding to global nuclear dangers like nuclear proliferation and nuclear terrorism. And they also include supporting the Navy's nuclear reactor program. In each of these mission sets, we work closely with our partners in the Department of Defense, the Department of State, and several other government agencies. And we carry out this important work through an extensive network of research and design laboratories, production facilities, and a national security site, formerly known as the Nevada National Test Site. Yesterday, in fact, I visited our Kansas City National Security Campus, formerly known as the Kansas City Plant, over in Kansas City, Missouri, which has primary responsibility for either producing, manufacturing, or procuring all of the non-nuclear components that make up a nuclear weapon. And that's about 80%, some say even as high as 90% of what goes in a nuclear warhead. And the campus also serves several other national security functions, and in fact, about a third of its budget is comprised of what we refer to as work for other or strategic partnership programs. Last year, our Kansas City operation moved from a World War II era 3.2 million square foot facility into a state-of-the-art manufacturing production facility. And in the process, we cut our footprint in half. We reduced our energy and maintenance cost, and we significantly enhanced our efficiency. Representative Hartzler, who was here earlier, was at the formal opening ceremony last year. And I know several of you have already visited, so for those of you who have not yet gotten over to that plant, particularly those of you from industry, I think you would benefit from seeing it. I told the folks at Kansas City yesterday that I was going to be making this invitation to you, so they will be expecting an influx of visitors, so please do. Sometime last time I was out here in the Whiteman area, I went out and visited the weapons storage area, talked to some of the maintenance technicians out there that are working on things that NNSA has a great interest in, and a lot of them had been over to Kansas City, and the Kansas City folks had also been out here. So I think there's great synergy between our two organizations, all the way down to the level of the touch labor associated with our enterprise. Now, our extensive network of laboratories, production plants, and our test center, which we refer to as the Nuclear Security Enterprise, has recently achieved several milestones in support of our enduring national security missions. I'm just going to share a couple of them with you. First of all, we continue to make important progress on our life extension programs, which we refer to as LEPs, life extension programs for our various warheads and weapons. And these life extension programs, or LEPs, address the challenges associated with the weapons components and thereby ensure the continued safety, security, and effectiveness of the nation's nuclear weapons stockpile. I can't recall if Admiral Haney said this, but the nuclear weapons stockpile, the nuclear arsenal that America has today, is the smallest it's been since the Eisenhower administration. It's also the oldest it has ever been. We had a practice in the past where during most of the Cold War we would design new nuclear weapons, we would fabricate them, we would test them out in Nevada and elsewhere, and we would put them into operational service, and we did that on about a decadal cycle. We are now in the business of extending the life of warheads, some of which are already 20 to 30 years old, and extending them for another 20, 30, or even longer. So this is new territory for the United States and for our nuclear security enterprise. But back to our LEPs, this past year, 2004, we reached the halfway point for production of the W76-1 warhead. That's one of two warheads associated with the submarine-launched ballistic missile force. We also successfully conducted several experiments critical to the life extension of the B-61 air-delivered gravity bomb, including fly-around and vibration tests on the F-15, the F-16, and the B-2. This life extension program is central to sustaining the air leg of the triad and extended deterrence for our allies and partners around the world. We are also continuing baseline design reviews on the W-88 alteration. The W-88 is the other warhead used by the Navy's SLBM force. During the fiscal year 2006 budget process, which I'll talk a little bit more about in a moment, a decision was made within the Nuclear Weapons Council that Admiral Haney referred to refresh the conventional high explosives during the course of this alteration of the W-88. So we, if Congress comes through with the money, we will in fact do that. And we're slated to deliver the first production unit of the W-88 alteration in fiscal year 2020. The Nuclear Weapons Council also decided to accelerate the first production unit of the W-80-4 life extension program by 2 years. In other words, moving it from when we were going to have a first production unit in 2027 to having a first production unit in 2025. This is the warhead that will be used on the Air Force's long-range standoff missile program, a replacement for the air-launched cruise missile. In addition to our life extension programs, we're also making exceptional progress on our modeling, simulation, and experimental campaigns, which enable us to assess this aging stockpile in the absence of nuclear explosive testing. In particular, the B-61-12 life extension program and recent decisions on the scope for the W-88 alt have all been firmly grounded in data and simulations. There's a facility at Los Alamos Lab called DART. It's one of those acronyms, let's see, Dual Axis Radiographic Hydrodynamic Test or something. Did I get that right, Chris? Is that close? Yeah, I'm getting some thumbs up from people who actually know more about this than I do. The DART facility at Los Alamos, which is one of those extraordinarily important, sophisticated diagnostic tools we use to conduct nuclear physics, nuclear chemistry, material science, just finished its 50th successful experiment. The advanced diagnostics of this facility and the data that it's producing provides key insights into the performance of materials within warheads. And experiments conducted at the National Ignition Facility at NIF in Lawrence Livermore Laboratory. Let me ask a question here. This is not in my script. Let me ask a question. How many of you have actually seen pictures of the inside of the NIF? How many of, there's not a lot of hands, how many of you saw the last Star Trek movie? And remember the reactor room in there? That was the National Ignition Facility. So you have actually seen it. It's not used for Star Trek types of activity. It's just it's cool science. And so Hollywood was very interested in it. But in any event, the NIF and other small-scale, high-energy density platforms are essential components of our stockpile stewardship program. The NIF in particular is now providing a steady series of experiments that inform us on the physics of nuclear weapons and is a key facility for the NNSA and indeed a key facility for the nation. And we recently completed the first plutonium experiment on NIF, and I'm told the results are outstanding. It's also worth noting that the shot rate, that's experiments, that's how we refer to experiments there, the shot rate at NIF has increased significantly and will approximately double from what it was in 2004 to 2015, from 175 shots per year to 300 shots per year. That may not sound very significant, but trust me, for the scientists and technicians who manage NIF, that is a huge accomplishment. So we're also making positive headway on our non-proliferation efforts, and one of the other mission sets that I mentioned. NSA made significant contributions to the third Nuclear Security Summit that was held in The Hague in 2014. At this summit, you may have read, the United States and Japan pledged to remove and dispose of all highly enriched uranium and separated plutonium from Japan's fast critical assembly, a type of reactor, an initiative that NNSA is playing a central role in carrying out. We're also actively working towards several other deliverables for the next Nuclear Security Summit, which will be held next year in 2016, somewhere in the United States. In 2014 alone, the NNSA partnered with 5 countries to remove 97 kilograms of highly enriched uranium and plutonium from civilian facilities, which brings the cumulative total at the end of 2014 to an impressive over 5,000 kilograms, about enough nuclear material to make about 200 nuclear weapons. And we're doing all of this to help ensure the security of special nuclear material around the world under the assumption that what a would-be proliferator needs, what a would-be nuclear terrorist needs is access to that material. So if we can lock it down, if we can minimize the amount of it that exists, we and the rest of the world are that much safer. And to prepare for future non-proliferation challenges, NNSA is drawing upon its deep, wide-ranging technical expertise to inform U.S. policy. This includes conducting research and development on new technologies to effectively monitor potential future agreements and to assess emerging technologies that could potentially pose new proliferation risks. Our counterterrorism and emergency response programs also accomplished a great deal, including sharing expertise and technology for the development of a software platform for the Federal Emergency Management Agency, which will better enable communication experts between DOE experts and state and local responders in case of, God forbid, a nuclear or radiological incident. You may not know this, but anytime you go to a large public gathering, such as the World Cup Soccer Championships or the World Ice Hockey Championships or the Super Bowl, that there are probably NNSA people there working with local law enforcement to be able to provide that kind of expert advice, again, if there is any sort of problem along those lines. And naval reactors continues its record of operational excellence. Naval reactors provided support for the resolution of any problems that the Navy's nuclear reactors may have encountered while the nuclear fleet safely steamed more than 2 million miles in 2014. Again, this is another thing that NNSA and NR nuclear reactors does that not many people know. They are the 1-800 number, the reach-back number if a aircraft carrier or a submarine, both fast attack and ballistic missile submarines, encounters a problem with a valve or a fitting or some other aspect, they call, reach back, and the experts who work for Admiral Richardson many times are able to troubleshoot those problems. They bring together scientists, technicians, and troubleshoot it, on the phone, as it were, and many times these issues can be resolved so that ships and submarines don't have to return to port to be fixed. saves large amounts of money, and it keeps the Navy on its deployment schedule. Naval reactors also made important strides in advancing the Ohio-class replacement. The reactor for the Ohio-class replacement, which many of you will know, will be a life-of-the-ship reactor, so that it will not be necessary to do a midlife refueling of that reactor. As a result of that, we save a lot of money in terms of the cost of refueling, but we also save a lot of money because we can buy 2 less submarines to replace the current fleet of ballistic missile submarines. So billions of dollars, tens of billions of dollars of savings to the United States because of the effort that the scientists, technicians, and engineers that work for Admiral Richardson are doing. Also this year, the NR delivered the first unit of the next generation aircraft carrier reactor for initial testing. So in order to support all these critical programmatic activities, we're making important strides in recapitalizing our aging infrastructure around the enterprise. As I mentioned, the Kansas City plant transitioned to a brand new building. Many facilities around the enterprise were either upgraded or torn down, and headway was made towards revitalizing other infrastructure as well. And we are, I think, more successfully moving towards recapitalizing our aging uranium and plutonium facilities, which are absolutely vital to our mission. So that's a lot of activities over the past year or so that, when taken together, I think paints a picture of a busy, learning, and hopefully continuously improving organization. So let me shift gears just a bit and talk a little bit about the future. And what a better place to start than the budget. After all, as some of you who've worked with me before have heard me say, you know, our plans are only so much ink on paper without the proper amount of funding or resources to carry them out. The President's fiscal year 2016 budget request, released in February, was a particularly strong one for NNSA. Bottom line figure was $12.6 billion as part of our request, up $1.2 billion or 10.2% over what the Congress actually appropriated to us in 2015. I'm pleased to report that our budget lines have increased across the board in this request. Due to budget constraints, this wasn't the case last year. However, this year's request reflects the strong priority that the administration places on NNSA's programs and NNSA's work. Also noteworthy is the fact that there is now a consensus within the principal agencies that comprise the nuclear weapons enterprise regarding what investments are needed to sustain the stockpile. This was achieved through the Nuclear Weapons Council and will help contribute to achieving a stable execution of programs going forward. Now, all of these programs are detailed in the congressionally mandated Stockpiled Stewardship Management Plan. We recently released an update version for 2016, and it's currently available on our website, nnsa.doe.gov. Several hundred pages of great detail about what we're doing, wonderful transparency. This report describes every aspect of our plan to maintain a safe, secure, and effective stockpile in the future. So if you need that data, that's the place to go to it. And this year, for the first time ever, we've also released a separate strategic plan modeled on the SSMP for our nonproliferation, counterterrorism, and emergency response programs. It also is on our website, nnsa.doe.gov, titled Prevent, Counter, and Respond. And it explains, again, in great detail, the rationale, content, and future direction of these key NNSA programs. Finally, to knit it all together, we will very soon release the overall NNSA strategic vision, and this document will provide an integrated guidepost for NNSA's leaders, our M&O partners, M&O management and operating contractor partners, our stakeholders, including local communities, and most importantly, I hope will provide clear direction and mission to everyone across the nuclear security enterprise. Taken together, these publications, I think, lay out in a very open way about what NNSA's missions are and how we hope to achieve it. So in reviewing all these things, I'm very optimistic about the future. Our missions remain enduring and essential to the security of this nation, our nuclear security. and it allows us to continue to be world leaders in science, technology, engineering, and industry associated with this most important strategic deterrent mission. However, we do face some challenges. One of the most serious challenges that we face in the NNSA, and oh, by the way, it's a challenge that the DOE also faces based on the internal and external reports that were done on the nuclear enterprise within the Department of Defense last year. One is of those challenge, over 50% of NNSA's critical facilities are more than 40 years old. Some even date back to the Manhattan Project and the early days of the Cold War. Just obtaining replacement parts for electrical, ventilation, fire protection, other systems is difficult. Also, our understanding of seismic events and their likely implications for buildings have changed significantly over the decades. Any shutdown in a key production line due to safety or security concerns related to these antiquated facilities could potentially halt operations that directly impact our programmatic work, including the life extension programs and other national security initiatives. Accordingly, we are investing in repair, maintenance, and replacement of critical infrastructure and facilities to provide for steady-state production that is needed to maintain the current stockpile and at the same time to be agile enough to respond to new or unforeseen requirements in the future. We are now focused on ensuring that we can provide for cost-effective plutonium and uranium operations over the longer term. As you may have read, we have fundamentally modified our approach to building new facilities for those two critical missions, plutonium operations at Los Alamos National Laboratory in New Mexico and uranium operations at the Y-12 plant in Oak Ridge, Tennessee. Instead of constructing a single, large, multi-purpose, big box facility to house all required capabilities, as we now plan to repurpose existing facilities as much as possible, and where new floor space is required to build smaller, separate facilities segregated by security and hazard category so that we can put facilities into the proper space. The cost of putting high security or building facilities for high security and high safety margin activities is obviously much higher than the cost per square foot of putting them in, building facilities for those that have lower security and safety requirements. Developing modern and more efficient physical infrastructure will also help us maintain world-class technical force. Modern facilities will help NNSA and its associated labs and production plants to recruit and retain a high-powered scientific, technical, and engineering workforce. We believe improvements to our predictive capabilities and the science that underpins them, combined with state-of-the-art tools to leverage this knowledge, are key to our success in attracting individuals to work for us. One of our first steps to obtaining these tools is being phased in over the next couple years. Our next advanced technology computer system, Trinity, will be delivered to Los Alamos in later this year, and will deliver over 40 petaflops of computing capability by 2016. Additionally, late last year, Secretary of Energy Moniz, announced a partnership between the Department of Energy, NNSA, and several labs across the DOE complex to invest in even higher performing high-performance computing. This initiative, which was dubbed Coral after Oak Ridge, Argonne, and Livermore labs, will allow the DOE complex to build state-of-the-art supercomputers to run the highly complex energy, science, and security mission applications to ensure U.S. leadership in these fields. And here we're talking about petaflop above 100 or more. Simulations on these modern platforms, coupled with technical experiments to validate these simulations, will provide meaningful and beneficial technical work for our skilled workforce. The entire nuclear security enterprise, and that includes both DOE and DOD, is, after all, in competition with academia and the commercial sector for the most talented graduates from our STEM programs across the country. Think about it. If you were fresh out of a high-powered science and engineering graduate program, and you face the choice of working in a tired, run-down facility, or alternatively going to a modern laboratory with advanced equipment and computing capabilities, whose job offer would you most likely be inclined to accept? So to counteract this, we are actively engaging and recruiting the next generation by partnering with academic institutions such as this one and offering opportunities to engage faculty and students in the STEM fields. The Stewardship Science Academic Alliances program, established in 2002, is a great example of this. This program funds projects at universities that conduct fundamental science and technology research of relevance to the NNSA and provides hands-on training to students who will be the next generation of leaders at our national laboratories. I was talking to, in fact, a lab director just a couple days ago who reminded me that's how he got started, as a young postdoc going to one of our national laboratories. Loved the science that he was doing, got hooked on the mission, and is still there today. Earlier this year, we announced a cybersecurity workforce pipeline consortium. This will be a $25 million grant over the next 5 years to establish a pipeline of cybersecurity experts from minority-serving institutions to the Department of Energy and NNSA and its labs. These and other programs are crucial to attracting talent, but it's equally important to retain these individuals over the long term. To do that, we need to ensure that our experts can stay up to speed in their fields with research opportunities through laboratory, site, and plant-directed research and development. This work is critical to our labs and plants as it fosters scientific innovation and provides funding to execute world-class science and engineering awarded through a competitive peer review process. This particular program, lab-directed research and development, is always under assault by those who would like to cut or cap the amount of money that we spend for lab-directed research. But let me tell you, again, talking to every one of the lab and plant directors, they will tell you that this funding is absolutely essential, not only to push back the frontiers of science and engineering, but also to keep high-quality graduates within their workforce. Well, I've covered a lot of ground this morning, and I'd like to leave some time to hear what's on your mind. So again, thank you, Joe. Thank you, Mark. Thank all the members of the Strategic Deterrent Coalition for inviting me to speak today, and to reiterate NNSA's appreciation for the excellent support that you provide for our common mission. So with that, I'm happy to take any questions that you may have. Instead of writing them down, I'm quite happy if you'll just stand up, shout them out. Please tell me who you are and where you're from. And if necessary for folks on the other side of the room to hear, or I guess we have some microphones here, I'll be happy to repeat it. So any questions?
Hello, General. Chris Yaw from Cadence, not Global Strike Command anymore. I almost made that mistake just now. There are some interesting and kind of disturbing trajectories in other countries as they come out with new nuclear capabilities. I'm thinking particularly Russia, China, but even North Korea and potentially Iran in the future. And it seems to me that at some point in the future, we may have to respond with new designs of our own, potentially off of new weapon systems. What is your confidence that the cadre that we have right now of new designers will be able to do that? And how can we work to assure the nation that?
Okay, and that's a very good question, Chris. Thanks for asking it. First of all, let me reiterate what U.S. policy is, as stated in the Nuclear Posture Review of 2010, signed out by then Secretary of Defense Bob Gates. It is the policy of the United States that we are not going to develop new nuclear weapons or new military capabilities for the nuclear weapons that we have. That does not mean that we will not do the things that are necessary to replace aging components and parts and extending the life and the safety and the security of the nuclear weapons that we have. And as I've just laid out, we have a fairly extensive program to do that under our weapons activities at NNSA and in partnership with the Department of Defense. My sense is again, I'm not a scientist, although I will hasten to add that the Sci in poli-sci stands for science. Had to say that. But my sense is, in traveling around to our labs and plants, that the scientific, engineering, and technical challenges that we've given to our physicists, chemists, computing specialists are really leading edge stuff. And the task of extending the life and doing the work that's necessary, the diagnostic work as well as the production work associated with that, exercises a lot of the skills that one might have traditionally found within the nuclear security enterprise. So, and they're busy, and they're excited, and they're enthusiastic. Nothing is more exciting than going into the NIF or to the Lance facility at Los Alamos or down to Sandia and seeing, I say young, everybody's younger than me, it seems these days, this young cadre of people, how enthusiastic they are about the work they're doing and the reason why they're doing that work. So I suppose I'm pretty optimistic that we have deep bench skills in the disciplines that are necessary to deal with whatever challenges, technical or political, military, may arise in the future.
Arnold Gordon Bray. How you doing, sir?
I'm doing great.
Just a question to kind of bridge what the Admiral talked about earlier, as well as a Army role, which is intel and intel collection. Two questions. How comfortable are you that we really know who has what and to what degree? And then the second thing, what do you think we're doing to improve our intel collection?
Okay. Those are good questions. Obviously, I can't talk too much about the specifics of intel collection and sources and methods, but let me say a couple general things. First of all, not many people know this, but the Department of Energy has a very competent, technical, well-respected intelligence function. And it goes all the way back to the very beginning. It all goes all the way back to General Leslie Groves and the Alsos project during the Second World War, when he sent some of his best scientists and military people into Germany, in some cases ahead of the advancing line, to try and track down what German scientists may have been doing in terms of a German nuclear program during the Second World War. And they in fact, I see some folks who have worked in that thing. So I'm very, very proud of what DOE has in its intelligence functions. The other thing I think that is extraordinarily important to bear in mind, and there's been a lot of press on this recently as a result of the negotiations with Iran that have been at the forefront of the news, in which our Secretary Moniz, has played a key role in. And that is the scientists and engineers and that we have within our national laboratories and within our production facilities have a deep understanding not only of our own nuclear capabilities, but what it takes to construct a nuclear program or to advance or modernize existing nuclear capabilities. So that is a great reservoir of understanding. So as we develop, as I mentioned earlier, some of those tools in the non-proliferation area or in the verification area, we draw very, very heavily upon that, that intellectual talent and expertise that lies out there in charting the way ahead. Okay.
We have time for one more question.
One more question. No one wants to be the last question before lunch, except that gentleman in the back. Bless you, sir. Bless you.
I apologize in advance for asking a nit, but nobody had a bigger question. So I'm asking you, sir, because I can't find the answer otherwhere. In the SSMP that came out last month, there is a line for the B6113. And I keep asking, what do we have in mind for that? And okay, if you could, no, you too? Okay.
You're going to have to show me the line.
Yeah, it's
Okay.
there. Okay.
All right, all right.
Thanks anyway.
Okay. All right. But for those of you who have not read the SSMP, please go to it, nnsa.doe.gov. How many of you follow Twitter? Any Twitter types in here? Okay. At Frank Klotz NNSA, all one word, you can follow, or at NNSA News, both of those Twitter accounts as well as our Facebook account. We're using that to, when we have something like the SSMP come out or our Prevent, Counter, Respond document on nuclear nonproliferation, counterterrorism, and emergency response, we will get the word out through those media as well. And we'll also give you a convenient link to click on to get to that. So I've got a question. Who's ready for lunch? Anybody? Okay. Thanks.